We're now going to use the eye model to create a gradient index lens inside the eye. So I'm going to zoom in, and we see that the eye lens has a multi-layered structure just like the real eye. So we're going to start AHEM, and I'm going to load a previous settings file. So now we have the GRIN lens selected, number 1, and most of the other parameters are similar to the default eye model. So we're just inserting the gradient index lens into the system. So I click OK, and I've got my next splash screen that's more dedicated to the gradient index lens, geometry settings. So I've got an unaccommodated thickness and an accommodated thickness. So what we can use this for is if we want to put accommodation on the lens, or if we want to simulate aging and the thickness associated with aging. We can also globally adjust the gradient index profile of that lens by adding or subtracting any amount we want to the individual layers. And we can show a table of those layers and adjust them further independently. So I have that box checked. And then the rest of this data is relevant to the geometry of the rest of the eye. Click OK. And I've got another new splash screen that shows the different layers and their different indexes. So the innermost layer is the embryonic nucleus, which would be this green layer. And as I go outward, I've got various changes in index. And so this is my gradient index lens profile for the various 13 layers of this lens. So we have an embryonic nucleus, a fetal nucleus, a juvenile nucleus, an adult nucleus, and a cortex. So as you age, you acquire these various nuclei due to the layering of the lens fibers onto the lens. I'll click OK. So we're creating our eye lens and our eye geometry, and we've got our tracing going on. So here we're looking at a point spread function of the gradient index lens eye model, and we have a retinal window of 1 by 1 millimeters. So this is a retinal image, and we've got a nice compact point spread function. The spherical aberration of the eye is much reduced by using a gradient index lens. That's an advantage to that system that we have in our eye. We can look at our graphic again here in 3 dimensions, and I can take away some parts of the eye so we can look at that eye lens in more detail. So I'm hiding the sclera, now I'm hiding the retina. And so here we see that onion-shaped eye lens. I'm going to zoom in a little bit here. And I'm also going to remove the cornea for viewing and some of these in the iris. So we can see we have 13 layers, and I can hide them, and you can see how the lens is structured as I hide the various layers. They're all on top of each other with different indexes. I can also assign different scatter properties to the individual layers as well. So if I want to simulate cortical cataract, I can put scatter models in the cortex. If I want to simulate nuclear cataract, I can put scatter models on the various parts of the nuclei. So I can simulate just about anything with the eye lens in a multi-layered gradient index application.